Hello and welcome to another Unreal Engine 5 tutorial. Today I am filled with an inconsolable righteous anger unlike anyone has ever felt before in the history of mankind. And the reason for that is because this is the third time I have tried to record this tutorial, but every single time I've done it, I haven't been able to replicate the camera system that I initially created for my notes. So we're going to give it one more try, and hopefully we will be able to replicate the camera system correctly. So yeah, we're going to be doing a camera system for a game like Crash Bandicoot. It's going to follow a rail, and you'll be able to change the camera angle and position on the fly, as well as have the camera tilt in different directions if desired, and also incorporate a dead zone. So let's see if we can't make this work. First things first, if you haven't already set this up on your character controller, we're going to need to change the way the camera works on the character. Because by default, the third-person character uses mouse or joystick input to control the camera, and obviously in Crash Bandicoot, we don't want that to happen. We want the camera to be as still as possible most of the time. So, in Unreal Engine 5, open up your third-person character, find movement input, and then we can clear this out. Then we are going to want, sorry, let me find this in my notes real quick. Yeah, so I'm going to get player camera manager, get actor right vector, vector snapped to grid. What vector snap to grid is going to do is basically limit the number of directions you can move in. So if I were to just get actor right vector in without vector snap to grid, it would still work perfectly fine, but you would be able to move in literally every direction, and sometimes when you're moving left and right in a platformer, you don't want to have that. Well, for example, if I'm moving right, but let's say I'm slightly pushing up on the controller because I'm like really into the game, without vector snap to grid, it's going to kind of push me back into the level. So what vector snap to grid is going to do with grid size 1 is basically limit me to the 4 cardinal directions and the 4 intermediate directions. Then we can duplicate this, move it over here, but instead of get actor right vector, we're going to get actor forward vector. Plug that in here, and plug that in here. And let's just test this out to make sure this works. Oh, oops. Okay. And it does not. So what happened there? Oh. And then you can just disconnect add controller yaw input and add controller pitch input. So yeah, now you have no control over the camera, and if we rotate the camera, the player's movement is always going to be relative to the camera. So if I press right, the character is always going to move to the right, even if the camera starts to rotate. So if the camera were to start to rotate and I was just holding down right, the character would start to move in a curved pattern to try to adjust to that new angle. Okay, So, back in our content folder, let's create a new folder, call it camera system. Open that up. I'm going to create a new blueprint. It's going to be an actor. Call it BP camera. Open that up. And gonna need a few things. So first things first, let's add a billboard. This is just personal preference because when you have all of these blueprints that trigger things in an environment but are not actually visible within a game, when you're editing the level, it can start to become a little bit cumbersome to see all these just boxes and not have any indication of what they do without clicking on them. And fortunately, Unreal has a camera billboard built right into it, so we can just click on the sprite and search for camera, and there we go. So I'm going to add a new spline to our mesh. This will be the rail that actually controls the camera. Then we're going to add a spring arm. Let's rotate that -90 degrees on the Z-axis. And make sure the spring arm is not parented to the spline, but is parented to the billboard. Then we're going to add a camera. And set its rotation to 0 on the Z-axis. And on our spring arm, let's set just a default kind of position for it. So socket offset, let's maybe do 150. Target arm length, maybe 300, 500. And then actually, let's go back to our camera and change the rotation on the Y-axis to -15. In our event graph, let's delete these for now, but we'll bring them back later. Going to set view target. Whoops. Let's actually get player controller. And from the return value, we're going to set view target with blend. Plug that in here. New view target is going to be self. And since we want this to instantly happen as soon as the level's loading, we don't need to mess with any of the blend stuff. Let's compile that, drag it out onto our level, rotate it 90 degrees. So it's just focused right on our character. And let's try it out. Okay, so an odd angle right off the bat, but you'll see as soon as we walk away, it fixes itself. And we are seeing the view from our camera. So we obviously don't want this to happen whenever our character walks through the spring arm. That can be a useful feature in some games, but not in this case. So to fix that, just click on spring arm, and on the right details panel, uncheck do collision test. And as you can see, we no longer have that issue of the spring arm running into our character. Okay, so for the camera, let's declare all of the variables we're going to be using. So first we're going to need one called active, another called starting camera, one called stationary, and one called look at character. So active is going to be which camera is actually providing us with the feed. It comes in handy if you need to have multiple different cameras in a scene, which happens sometimes. Then we have starting camera, so this will be an exposed variable, and you will basically just check this to enabled when you know which camera the level is going to start with. And so that means it'll be the first in the priority. Then we're going to have stationary here. What that'll do is sometimes you may want to switch to a camera that doesn't move at all. So this will just disable any motion we have. And then look at character. So a good example of this happens a lot in Crash Bandicoot 4 when you're moving into a level rather than side-scrolling. You might notice there's like a subtle sort of tilt to the camera. It just follows you just a little bit so that you're never out of view. And so that's what that bool is going to do. Next, going to have look at dampening, or no, yeah, we actually don't need that. I tried that earlier, but it really didn't work. So then instead of that, let's do socket offset. And that is going to be a vector. That's just going to be our default camera position. Expose that. And we need transition time, which will be a float. Then target offset, which will be a transform. And I like to keep things color coded, so I'm gonna chromatically organize these. Don't judge me. And then easing function, whoops. And that is going to be an easing func. Then linked camera, which will be APP camera. And default world rotation, which will be a rotator. So what each of these is going to do, like I said, socket offset is just going to be the default orientation of the camera. Target offset is going to be when you're switching, kind of if you want to change your camera the way that it looks, that's what that's going to do. Then transition time is in between those changes, how long that takes. Easing function is kind of the character of the motion as we transition. Then linked camera is like a bit of a special use case for when we want to transition between cameras. And then default world rotation is just going to be here so that if we use look at character and kind of tilt the camera to follow our player, default world rotation is going to be there to reset us back to our original rotation when we leave areas that use look at character. Okay, so let's finish off begin play here. I'm going to drag out default world rotation. I'm going to get camera, get relative rotation, plug that in here. Then we're going to branch. This is the starting camera. We are going to set our view target. If not, we're not going to do anything. So we're going to set the camera to be active. And then we're going to set world location of the spring arm. And we are going to drag out our spline and find location closest to world location. Plug that in there, set coordinate space to world. And we're going to get player character, get actor rotation. Or excuse me, get actor location. Plug that in here. And there we go. So what this last bit is going to do is, if you've got a particularly long level and you want to test different parts of it, when you right click and say play from here, if this wasn't here, the camera would stream. You would have to transition and move all the way through the entire level before it got to where you are currently. And that can be kind of annoying if you're just trying to test like one small thing, but every time you make a change, you have to go through the entire level on a track. And then additionally, if you set up checkpoints later on down the line, this will make sure that the camera starts at that checkpoint right at the beginning, or rather than right at the beginning. Okay, so up next, let's do our tick function. First things first, we're going to add a timeline. Wait, no, sorry. First, we're going to set world location. Yeah. Set world location spring arm. And we're going to find location closest to world location. It's going to be world. Then we can just duplicate this, the get player character and get actor location, and just plug that in here. And now the camera should follow our character around. So let's test that out. Let's make our rail a little bit longer. So yeah, now as you can see, as long as well, that didn't work at all, did it? What's going wrong? So we have our spline. Oh, we haven't set this as our starting camera. Okay. So make sure you enable your starting camera. Okay, so as you can see, if I move over to the left where there is no rail, the camera does not follow me. But as I come to the right, the camera will follow me as long as it can. That's all fine and dandy, but it's not very smooth. So let's smooth out its motion a little bit. So drag up from here, V interp 2. Then let's Control-click current and drag it down to target instead. Delta time, let's get world delta seconds. Interp speed is going to be 2. Then we're going to drag out spring arm, get world location, and find location closest to world location on our spline. Set that to world and plug that into current. And then we can plug the V-interp into the new location for set world location. Compile that, let's try it out. So yeah, now we've got kind of a nice smoothed out motion as we run around. Cool. So let's add in a dead zone. So, I believe I mentioned it earlier, but in a platformer, you want the camera to move as little as possible. And that's just because it becomes disorienting and kind of gives me a bit of a headache if there's too much motion in the camera going on. So you want it to be either still or kind of locked to the character as much as possible. You can sometimes, in some games, it's better to just go into the spring arm and enable camera lag. However, that doesn't really work in this particular instance. There's just a bit too much motion. But you can experiment with the lag settings as much as you want. And so yeah, let's set up that dead zone. So click on your billboard, then we're going to add sphere collision. Call that dead zone. Set its radius to something like 65, just to try out. There's our dead zone. And let's duplicate set world location. Gonna put that first in front of our other one. And what we want it to do is follow our character, but not one-to-one. So we're going to V-interp 2. From here, we're going to, well, actually, let's grab our dead zone, get world location, plug that into current, then get player character, and get actor location, plug that into target. Get world delta seconds for our delta time, and 2 for our interp speed is fine, I think. And then get our dead zone, plug it in here, and let's unhide our dead zone so we can see it working in the game. Let's try it out. So I know it's a little hard to see, but if you have it on high enough resolution, you can see the sphere sort of moving around following me. And let's make its radius a little bit bigger. Let's make it 100. So from there, I'm going to actually disable the movement while we're in the dead zone. So let's get our dead zone is overlapping actor. That's true. We're going to branch So if we're overlapping the actor, we're not going to do anything, but if we are not overlapping the actor, we are going to follow the actor around. And then just get player character for the other actor in our overlapping actor bit. So as you can see, I'm inside the dead zone and the camera's not moving. But as soon as I step out of it, it starts to move. So there is a problem here, and maybe it's already occurred to you, but so the rail extends off to the right here, but if I'm moving very slowly through a level, like maybe there's a bunch of obstacles in my way or a bunch of boxes that I need to break, as we keep moving, the dead zone is just stuck on me, and I never get the opportunity to leave. So as we keep moving, I can actually leave the camera and break its functionality when I shouldn't be able to. So to address that, we're gonna do a fancy little trick. So from tick at the beginning, we're going to branch. And first we're going to get player controller. Then we're going to get player character. Get actor location. Then we are going to, from our player controller, we're going to convert world location to screen location. Plug get actor location into world location. And then from screen location, we're going to convert to a vector. And in this float, we're going to put 1. I don't know why Unreal wants this in here, but if you just do the math using 2D vectors, this doesn't work. But if they do it with 3D vectors, it works perfectly fine. So then we're going to get viewport size, duplicate our conversion node, also with a float of 1. And then we're going to divide. Going to divide the screen location by the viewport size. We're going to break that vector over here. And from each x and y, we're going to get an in range. Let's do 0.25 and 0.75 on x. And maybe 0.15 and 0.85 on y. We're going to say not with a not boolean. Then an or boolean. And connect all this back down to our branch. And because we're not monsters, we're gonna tidy it up by double clicking on the lines to create these nice little wires. Okay, so what this is doing is we are finding out where the player is on the screen. It's just the X and Y location. Then we're checking that against the viewport size and getting a fraction from it. And if the player is not within a specified box on the screen, which is declared right here, then we're going to stop the dead zone from moving so that the player is forced out of it, which then triggers the camera to move. And then just disconnect true and reconnect it false to set world location. So let's try that out. So there, I'm 3/4 of the way through, and as you can see, if I move back towards the center, the dead zone moves, but as soon as I get to that 3/4 mark, it stops. But it still doesn't work. And that's because we haven't set anything in our true section yet. So dragging out from true, we're going to branch up here. And then this is a bit odd, but we're just going to connect the return value from isOverlappingActor into this branch, and then drag false into the set world location. And that should fix this up. Come on. Okay. So now our dead zone is stopped, but as soon as we exit, it works again. Yeah, I have no idea why that's the case. I haven't given a whole lot of thought. I just know that it works. So if you know why it works, comment below, and I'll probably read it. What an incentive. Okay. So now let's do the look at function. First, let's just pull out our rail a little bit more so that we have a section that's going into the world. Try that out. It's working fine. So from set world location, we're going to branch, get our look at character bool, and we're going to set relative rotation up here, and that's going to be of our camera. Then what we need to do is get our camera, get world transform, and find relative look at rotation, and get the player character, get actor location, and plug that into our target location. Then from here, we're going to rinterp2. Then we can get our camera, get relative rotation, plug that into, plug relative rotation into current, and then relative look at rotation into target. Then we're going to get world delta seconds and set interp speed to 2. Then plug this up into set relative rotation. So let's, well, actually, no, yeah, we can still test this out. Okay. So let's just go to look at character and enable it in our blueprint. So in the side scrolling sections, it doesn't typically show up in Crash Bandicoot games, but in the forward sections, there's generally a little bit of movement there to follow us around. But we don't want this on all the time, so let's disable it. And let's create the volume that allows us to trigger that attribute. So back in our camera system, let's create a new blueprint class. Call it BP camera modifier. Open that up. We need billboard. Make it a camera again. Then add a box collision. Go into our construction script. All right, yeah. And then this is just so that you don't have to click a bunch of things or use scale, just so you have a nice little option right here on your blueprint. You're going to drag out from box, set box extent, promote in box extent to a variable. Congrats. Plug that in. And let's change inbox extent to collision boundary. And then expose that variable. So now, if we drag out our camera modifier, you can see there is no collision boundary because it's set to 0, 0, 0. But if we were to set it to 100, 100, 100, now you can see a box has appeared. And that just makes it a little easier rather than clicking on this and then clicking on box and setting extent. Okay, so yeah, and let's actually set our default collision boundary to 100, 100, 100. Okay, then in our event graph, get rid of this, get rid of this. We're going to, from actor begin overlap, we're going to check if it's overlapping the player character. If that's true, then we are going to call an interface. Now we need to actually create an interface in order to call it. So let's do that here. Right click, get a blueprint interface. Let's call it BPI camera interface. Open that up. And for our function, let's just do, let's call that function set new camera attributes. For our inputs, we're going to have stationary, then look at character, then offset. Offset is going to be transform. Let's actually call it target offset. Then transition time. That'll be float. Easing, whoops. Easing function. That'll be an easing function. And linked camera, and that will be a BP camera. Compile this, save it, and then this is not actually going to do anything, but let's just create a bool, call it success, and what this is going to do is when we integrate the interface, it will appear as a function and not an event. Okay, so then back in our camera modifier, let's do set new camera attributes. Going to get player controller, get view target. Plug that into target. Then going to promote each of these to a variable. And then we're going to expose each of those to the editor so that we can edit them. Okay, so let's see. Yep, there we have all of our options that we just set up. Actually, let's set some default values because that can sometimes break things if we don't have those set up. So for transition time, let's do 3. For easing function, I like circular in out. And the rest we can just leave as they are. Okay, close our camera interface and modifier. I don't think we're going to need to touch those again, but there's always a chance. And then back in camera, let's go into class settings and add BPI camera interface. Now that we've done that, over on our left we have new functions in our interfaces section. Double click here. And what we're going to want to do here is basically just set all of the variables that we got from our modifier blueprint. So stationary, we'll connect to stationary. Yeah, look at, and so on and so forth. Whoops. Yeah, make sure all of these are connected just to these variables and there's no target underneath any of these. Okay. Then we need to do something else, which is create a new custom event. I'm going to call that transition camera volume, or just transition camera is actually fine. Before we forget, go back into set new camera attributes and transition camera right at the end there. Okay, so on transition camera, going to drag out a timeline. Call that transform timeline. Let's connect play. Let's make it play from start instead. Then we're going to set yeah, so from spring arm, going to set target offset. And then we're going to set relative rotation. From target offset, we're going to ease this, but we need something to ease it with. So double click on transform timeline, add float track. Let's do 0, 0 for our first key, and 1, 1 for our second key. Then set our length to 1, and let's call this alpha. Then we have a new pin connection on our timeline. Plug that right in here. Grab our easing function, plug that into function. From A, we're going to get our spring arm, get target offset, just plug that in there, and then we're going to get our target offset, split that struct pin, and connect that to B. Right. And we're going to do the same thing over here. Get an ease. Get our function, alpha. And we're going to get the relative rotation of our spring arm. And then we're just going to get the offset rotation from our target offset transform. Actually, let's rename that right now, because that's not an accurate name. Call it target transform. Let's do that in each of our blueprints. Just for maximum clarity. And that's going to break our functions a little bit, but just option click to delete the bad connection and then just reconnect. Should be good. Okay, so let's try this out. So for our first little test, we're going to put a camera volume here. And that's just going to, on our target transform, let's move it back 200. And then up here, let's do that look at character. See how that works. Well, it did work, but not in the way we intended. Why didn't that work? Yeah. I think in our camera modifier, we need to set a default value with a rotation of -90 on target transform because I turned the camera initially. No, that's not it. Weird, I don't know what that is. Hopefully that's not affecting anything. So why are you not rotating the way I would like for you to rotate? Okay. Yeah. Okay, so we're going to need to address that, I think. Yeah. Okay, so little hiccup there. Let's make sure our target transform is still set to 0 on everything. Let's just try that out real quick. Yeah. So this means that you can't actually rotate the camera. That doesn't seem right to me. That seems like an injustice upon humanity. Okay, so I think to fix that issue where we were having it rotate in an undesirable direction, let's try something real quick. Let's go into our construction script on the camera. And let's get our spring arm, set socket offset. And then get our socket offset from our variables. And then let's get actor rotation. And with our actor rotation, we're going to set world rotation of our spring arm. And then let's then just set actor rotation back to default. And that's not working. Can't delete that. Okay, so that's not going to work. Okay, so just delete this section here, but keep set target offset. So basically what this means is just don't rotate. And I should still be able to rotate it. Okay, so I guess, yeah, I think that just means let's not adjust any rotations in the socket initially. But yeah, that all still works fine. Okay. So yeah, just to keep things clear, you can rotate the camera initially, but keep the spring arm Z rotation equal, or just keep it at 0 initially. Yeah. Okay, but let's get back to testing this. Okay. So we passed through that first one and zoomed out. And when we entered that second one, we started doing the look at. So when you're actually creating levels, you will want to create a second area that's just set to just have its location set to your initial location. And same thing with this. So that an uncheck look at character, so that way when you go back through that boundary, it'll reset itself again. Okay, so those transitions are a little jarring in my opinion. So the way that you can address that is by editing your timeline, or we can make it a little more customizable, which is what I always prefer. And so let's do that. So let's set play rate. Whoops. Need to do that from our timeline. So in your components section, drag out transform timeline, set play rate. New rate is going to be 1. It's going to be 1 over our transition time. Compile that. Plug that in here, plug that in there. And now, if this were, I believe they're all set to 3 by default, so now there's a much smoother transition there. Let's try making this 5. Let's see how that works. So I think we're getting a little bit of a ugly sort of jump when we enter the set relative rotation or the look at rotation section. But I think the way, hopefully, to address that is to break our rotator and make a new rotator. Just plug Z into Z. And then plug that into, whoops, no, we want to plug that into B. Nope. Okay, let's try breaking this rotator and getting our X and Y, making the new rotator that. Nope, still kind of ugly. Is that what's causing it? Nope. Let's get rid of this and just plug in transform rotation here. But is that the problem? Seems like the camera is looking up when we do that. Why is it looking up? Okay, so I think that did it. So now run over here, it zooms out, come back, zooms back in, move down this way, and we've got that nice subtle transition. Cool. So what I did to fix that kind of jerky movement is just up here on set relative rotation for the branch look at character, which is at the end of tick. Just change that interp speed to 0.5. And then while I was troubleshooting, I also noticed that default world rotation is a bit of a misnomer. So let's change that to default relative rotation, because that's what it actually is. Okay, so we already have a pretty decent system here, but let's make it do just a little bit more. So I don't think stationary does anything yet. Let's check that, see. Yeah, so we haven't set up stationary or transitions for cameras yet. So to do this, let's first go to tick. I'm going to put a branch. And we're going to, from the condition, we're going to get an and. So if our camera is active and it is not stationary, then it is going to move. But if it's not active or if it is stationary, it's not going to move, because we don't need the camera to be doing anything if it's not the active camera, and we don't want it to move if it is active but it's a stationary camera. So let's try that out. Just make this stationary. And pauses right there. But if we come back, it enters again. Now that's one way it can be done, but it's not very controllable. So let's make it a little bit more interesting. Let's uncheck stationary before we forget here. And now we're going to use that mysterious linked camera that we've been avoiding this whole time, so that we can sort of switch between cameras and get more control over our camera angles. So on transition camera, gonna add some new stuff. On our after set play rate, we're going to get linked camera, right click the left side of it, and convert to validated get. Plug that in. Plug is not valid into play from start. And is valid, we're going to get player controller and set view target with blend. Our new view target is going to be our linked camera. Plug that into is valid. Blend time can be transition time. And blend function, let's just do ease in out. Unfortunately, this does not line up. It's not the same type of enumerator as our easing function, so we can't use that. And then for blend exponent, let's do 2. A little note about this. We have this last thing here called lock outgoing. Now I prefer to leave it unchecked because it makes it smoother. However, you may want to keep it checked depending on the needs of your game. What it does is if it's unchecked, the camera's existing momentum is going to be kept so that when you enter into a new camera, it's going to more smoothly transition to that camera. If it's checked, it's going to cancel out any existing motion and get all of its motion from the blend function. Now, why would you want that? It's more reliable. If it's unchecked, there may be a situation where you transition from one camera into another, and then you transition back into that initial camera, or you transition into a third camera. And if you try to transition into a third camera while the first transition is still running, then what Unreal does to address that is it just snaps to the third camera, and it's pretty ugly. So that's just something to kind of be aware of when you're designing levels. Try to avoid having situations where you can transition into a camera and then transition back really quickly, or transition into a third camera. And actually, the way I deal with that typically is I just kind of keep those volumes far apart from each other so that there's not enough time for the player to go back and forth while the transition is still running. But another way to deal with it is to just add a timer and prevent this from running while that timer is running. Okay, so from here, let's get active. Set it to unchecked because the camera that we're transitioning from no longer needs to be enabled. Then, whoops, sorry, we don't actually want that. Let's get our linked camera, and we are going to set target transform. We're going to get target transform, plug that in there. Then let's get transition time, set that, plug it into our existing variable, then set easing function, plug that in there, and then finally we're going to make this camera active. So we're going to set active to true. And then we're going to wrap this around and plug it into play from start. So let's try that out. Let's get a new camera. Drag that out here. And let's say you just have a little branch in your level where you can come up to this section here, and you want the player to be able to break off the beaten path. So to get it to transition cameras, all you have to do is press this eyedropper and then select the camera you want to transition into there. And then to get the camera to transition back, let's create a new volume, click our eyedropper on the new volume, and then select our original camera. And then let's set this right here to stationary because this kind of looks like a stationary camera. Okay, so far so good. However, there is an interesting break there. And I think that's because, yeah, I rotated the camera incorrectly. And that's that jump I was talking about. Thought I noticed something odd there. Yeah, there it is. Okay, so we don't actually want this to connect back to transform timeline. Now let's test this out, not stationary. So let's make this just a regular camera. So yeah, I'm working with our new camera. I thought I saw something a little odd there though. No, I think that actually works okay. Yeah, so cool. So here's our camera. It's performing its turning duties here. Come back. Maybe we'll want to branch. The camera does a nice transition here. Oh my god. I'm so glad that worked. You don't even know. Like I said before, I've tried making this video 3 times, and I don't know why it kept breaking, but I'm so thankful that it worked this time. So I am totally anticipating problems with this in yours, so if you have problems recreating this, let me know and maybe I can help assist you. Other than that, this has been another Unreal Engine 5 tutorial. Let me know what kind of stuff you'd like to see me make in the future, and with that being said, I'll catch you guys next time.